We're going to be reviewing trig. I think I said yesterday, and my goal is for you to get so good at trig that it becomes yawny, boring, almost I can get the right answer as fast as I can write by minimal thinking. It's almost become a habit. So, in theory, this is review. I'll teach it from scratch. Trigonometry, the study of three-sided shapes. Mostly for the first couple of units, we're going to be dealing with what we call right-angle trig. Chan coming in. To your left, to your right. We're going to be dealing with right-angle trigonometry, which is easier. We will also eventually be looking at non-right-angle trigonometry, where we bring out the sine law and we bring out the cosine law. And I have a math degree. As far as I know, I don't think there is a tangent law, because it's irrelevant and redundant. So, the first trig trick, and I think you learned this in grade 7 or grade 8, is solving something like this. They give you a right-angled triangle, they give you two sides, and they say, find the third side. How on earth can we do that? There is a theorem, a very famous one. Anybody? It begins with the letter P. Okay, Pythagoras. What is Pythagoras' theorem? It's alphabetical. It's a nice one. It's usually the one most people remember even into their adulthood. Gurja, what was it? Loud and proud, kiddo. Not is it, but it is. Here we go. Equals. Let's write this down. I'm totally fine if you never write that down again, if you go straight to numbers. The key to remember for Pythagoras, the only thing you have to remember for Pythagoras is only one side can go where the c squared is. What has to go where the c squared is? The hypotenuse. So how do we show that? You haven't had me. I'm organized but lazy. I want to have maximum organization for minimum writing. So how can I show that? How about this, Zach? I'm going to draw a little arrow. That's going to be my study reminder to let me know, hey, make sure that that goes there. I will never write this step again. I will go straight to numbers. So I would normally have just written, we have 55 squared plus x squared equals 73 squared. We need to get the x squared by itself. How, oh pray tell? Minus the 55 squared. That would get the x squared by itself. Okay, I'll write this out just once, but then from now on, I'm either going to show one line for Pythagoras or no lines for Pythagoras. If you can reach the point where Pythagoras, Josh, is pull your calculator out, squared, squared, square root, or squared minus squared, square root, done, good. Now on a test, will I show no work? I'll write a couple lines, but in your homework, I will assume you didn't just copy the answer. So just this once, I'm going to go x squared equals 73 squared minus 55 squared square root. Oh, in order to do this, you can write a little note here, I guess. Pythagoras. This is where, again, you need to learn how to use your calculator. Typically, for complicated multi-term square roots, I type what's inside the square root first, and then I go square root answer button. Some of the newer calculators, when you hit the square root button, it kind of does like a bracket indentation, and it puts the square root sign over everything that you're writing. You can probably do it in one step and stay organized. It's just on my calculator, it gets a little tricky to get organized, and I get, oh, it works out evenly. 48, yes? Are there units? Yep. I'm fussy on units. If there are units and you don't write them, I'm taking a half mark off. Oh, how many sig figs do we go to? In Physics 12, give every answer to 2 or 3 sig figs. We're not going to do sig figs properly. Okay. Example 2 says find the missing side. I am perfectly fine if you look at that and you say, oh, it's going to be x squared plus 7.6 squared equals 19.3 squared. And I'm perfectly fine, Zach, if you say, dude, it's going to be 19.3 squared minus 7.6 squared. It's going to be the square root of that. And if you can go straight to the answer of 19.1, I'm good with that. Now, I'll write a little bit of work. I'll write one line. X squared plus 7.6 squared equals 19.3 squared. Stephen, also, you haven't had me before. This is as neat as I write. It only gets uglier and messier from here, which is also why I type everything. Am I right? Is it 19.1? Did I make a typo? Oh, I did make a typo, Mr. Dewick. The square didn't show up. Good gosh, let's try that again. It wasn't making sense to me that because that side looked shorter than the hypotenuse. Do you get 17.74, 17.7? 18 I'd take to 2 sig figs. I'll go 17.7. Is that right? And these units are also centimeters. That's Pythagoras. Did you do that in Math 8, I think? Yeah. I think that's what they use to kind of show you square roots and that they're useful. No? Like, I know you did it before Math 10, I think, right? Yeah. Math 9? Okay. The better trig that you learn in Math 10 is what we sarcastically call SOHCAHTOA, right-angled trig. But first of all, you have to be able to label sides. So here is a triangle. Every triangle has 3 sides, Captain Obvious. Here is angle theta, right there. Typically, we use the variable theta for an angle. It's math shorthand. For example, if I see something like this, I know you're probably talking about graphing points. If I see this, I know you're probably talking about an angle. If I see that, I know you're probably talking about a radius of a circle. We have some shorthand in math that we use. So I will typically use the variable theta, which is like a 0 wearing a belt, for my angle variable. Every triangle has 3 sides. There's angle theta. What do I call? Oh, got a latecomer. Pause the video. So you ready? This side right here, opposite, adjacent, or hypotenuse. Adjacent. How can you remember that? Part of it is the English word adjacent. Well, actually, typically what I do is I identify the easiest side. What's the easiest side to identify in this opposite, adjacent, and hypotenuse? What's the easiest side to identify? So I typically label that with an H. The word adjacent means beside. Chang and Brian are adjacent to each other. What's the side that's beside theta? It's going to be the hypotenuse. Is always going to be one of them, but we've identified that. What's left? Adjacent. What do I call this side up here? Opposite. Opposite means facing. Right now, Patrick and I are opposite each other. On a cross. Now, of course, kids, when they first see this, they think, oh, the top side is always going to be opposite, the vertical side is always going to be adjacent, and Zach, thankfully, is shaking his head. It depends which angle we're talking about. If suddenly this was my angle theta, then that would be opposite, and that would be adjacent. Hypotenuse never changes. We also have 3 primary trig ratios. What are they called? They're buttons on your calculator. What's the first one? Did somebody say sin? It's sine. It's a sin to call sine sin. Sin is when you swear in my class. Sine is the trig function. What's the second one? What's the third one? Typically abbreviated sine, cos, and tan, right? So, we used to, when I was young, do this by hand. We had trig tables and it was a pain. You have all these numbers built in, you have all these functions built into your calculator. So on your calculator right now, can you evaluate sine of 42 to 4 decimal places? This is also to make certain that your calculator is in the right mode. I think I did my Jordan dying cow wood chipper story yesterday, I think, yes? What is the sine of 42 degrees to 4 decimal places? And for trig functions, if I'm using the trig function to find something, that's where I'll typically carry 4 or 5 or 6, or try and use my answer button, which I tried to drum into you last year. Let me just try this again. Sine of 42, 0.6691, 3 if you want to go one more digit. If you didn't get that, you're in the wrong mode, and now is the time to let me know. 0.66, what was it? 13? 0.6, what am I typing, Mr. Duke? 0.6691. This is why I use the answer button. Yet again, Linnea or not? Figured it out? Okay. Good. Find the next three on your own. Quickly. I have a few of these memorized. I know the tangent of 45 is 1. Bang even. I know the sine of 30 is 0.5. I know the cosine of 30 is 0.866. Yeah. Yeah. What did I write? You get an error, yes? Yeah, get an error. Do you? Yes? You know what? Let's see if we can figure out what's going on there. What's the tangent of 89 degrees? Go tan 89. What do you get? 57. Can you go tan of 89.9? Let's see if we can sneak up on 90. In calculus, we call this taking a limit. 573. Can you go tan of 89 point and then 4 nines after that? So 89.99999. Getting bigger? If you want, technically, tangent of 90 is, it approaches infinity. And I think we've then, because it gets closer and closer and closer and closer and closer to infinity, the closer you zoom into it, we may have even defined it as being infinity. It's not actually equal to infinity. We have to define it that way. Why is that, Mr. Dewick? Oh, we'll talk about that another time. We can also use our calculator to go backwards. Not only can I give you an angle and then you say, tell me the sine or the cosine or the tangent value, I can give you the sine or the cosine or the tangent value and say, tell me the angle. How do you go backwards? This is where it varies from calculator to calculator to calculator. But if I tell you that the tangent of theta is 3.732, how can I figure out what theta is? Does anybody remember how to do this? It's not really negative. They use a -1 symbol, which stands for inverse. Most of you, it'll be the button near the top left of your calculator. It'll be an inverse button or a second function button or a shift button, and you go shift, tan. Mine opens up a bracket automatically. Yours may or may not. 3.732, close bracket. And if I hit enter, that gives me 74.9998. Really, how many degrees is that? Where did I start with? 75 degrees. Typically for angles, I'll go to 2, maybe 3 sig figs, but one degree is only about this big. 0.1 of a degree, probably you can't even spot with your naked eye, so I never go much more accurate than 0.1 of a degree. So I'm going to go 75 degrees. Does that, everybody get that okay? Or this is also your chance to ask me how to figure out your calculator. Okay? All working? Good. Fill in the next 3 angles, please. If sine of A is 0.5, tell me angle A. If cosine of theta is 0.5, tell me theta. And if tangent of theta is 0.4877, tell me theta. This one I don't have memorized. Yep. Gurjo, you don't realize how profound this is. We used to do this with tables. You actually had every angle from 0 to 90 on the side and the decimals. So there'd be one row for 1 degree, and then up here was 1.1 degree, 1.2 degrees, 1.3 degrees. But here's what this allowed you to do, the same thing that you do on your calculator. The fact that I have access to trig tables on my calculator on a piece of paper, whoo, changes the world. Recall the definitions, next page, of sine and cosine and tangent. We use an acronym called SOHCAHTOA in English. because sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And by putting together the definitions of what sine, cosine, and tangent are, along with the numerical values of what sine, cosine, and tangent are, lo and behold, we've invented trigonometry. We can now solve for missing sides, which we're going to do a lot. So example 6 says, determine the length of the indicated side to the nearest 0.1 centimeters. We start out by labeling our triangle. First of all, is this a Pythagoras question? Really, I can use Pythagoras? Why can't I use Pythagoras? Pythagoras only works if I have two sides, find the third. Do I have two sides, find the third? And any? Nope. This is going to be trig. I start out by, first of all, identifying what my angle is. I have a habit of wherever the angle is, I typically color in the corner just to really reinforce, because if I'm going to make a dumb mistake, and it's going to be in my opposite and adjacent labeling. If I'm in a rush, I'll do something dumb. I've learned doing that little 1 second hack gets rid of 99% of my dumbness. Not all of it, because, you know, me. Then I look at the x, opposite, adjacent, or hypotenuse. Opposite, I put an O there. I look at the 15. Hypotenuse, I put an H there. I'm going to give you some advice. I completely ignore the blank side and I don't label it. There are some teachers, and I think this, at risk, I'll say, I think this is bad teaching. There are some teachers who always say, well, just label all three sides. Why would I add an extra letter to my diagram and make it more confusing? Because right now, all I have are O and H, which makes it pretty obvious which trig function am I dealing with. Go look at SOHCAHTOA up there. Which trig function am I dealing with? Sine. If I put the A on there, I've done extra work, and I have to now eliminate the A in my head and make sure I don't accidentally pick it. That's doing more work to make it more difficult. To me, that's silly. So you'll only see me label two sides. Sine. What always goes next to the trig function? The angle. What always goes next to the trig function? The angle. Alec, what always goes next to the trig function? There you go, which in this case is 57 degrees equals, oh, it's opposite over hypotenuse, x over 15. I want to get the x by itself. I need to move that 15. Hey, what's the 15 doing to the x? Adding, subtracting, multiplying, or dividing? How will I move the 15 over? I'll write this in my notes right now. But if you can write down the trig function, that first line that I wrote, and go straight to the answer on your calculator, showing no work, not only am I good with that, I encourage that. Let's get good at trig. Let's get triggy with it. Triggy. Okay. You get 12.6? Set to one decimal place. Yeah, there it did. 12.6? 12.6 centimeters. Next one. There's my angle. That 11.1, opposite, adjacent, or hypotenuse? Opposite? What about the x? Adjacent. I'm going to leave the hypotenuse blank. I don't care. Wah. O and A. Wah. Which trig function? Tan? What always goes next to the trig function, Alec?
The angle.
Please remember that. I'm going to come back to you. Equals what over what? 11.1 over x. Where is the x right now? Ugh, bottom. Wait. Ready? We're going to do some formula manipulation here. Dividing by x on this side is the same as what on this side? So, that's the same equation. I've changed it, but that still means the same thing. So I have x tan 28 equals 11.1. I want to get the x by itself. And I do have it on the top now, Taylor, yes? What's that tan 28 doing to the x? How will I move it over? Okay. I'm going to go straight to the answer. Okay, you know what? This is our notes. I'll write it out. But in your homework, if you can go straight to the answer, I'm good with that. So I'll write x equals 11.1 divided by tan 28. And some of you may even have just memorized, hey, when the x is on the bottom, I divide. Hey, when the x is on top, I don't care how you get there, but I want you to get good at trig. You get 20.9? The other thing is, we'll try and draw our diagrams roughly to scale. So I always glance at the shape and make sure, yeah, that makes sense. This side definitely looks longer than this side. I was expecting an answer bigger than 11.1. In fact, this side looks roughly twice as long as this. I'm good with that. Earlier, when I made the dumb mistake on this Pythagoras question here, and I ended up with, what did I say, 19.1? If this is 19.3 and that's 19.1, that didn't look right to me because that top side was shorter than the 19.3. I would have caught that by looking at the diagram and just say, it doesn't look right. I'm not going to draw my diagrams bang on to scale, but they'll be roughly to scale. Can also find angles. By the way, in this next question, part A, for example 7, I could use Pythagoras to find a missing side, if they wanted me to, but they said find an angle. Which angle? Angle X. I'll color it in. That's the one I'm talking about. Chang, that's 7, opposite, adjacent, or hypotenuse. That 15. Which trig function? A over H. A and H. Yep. Cosine. Alec, what always goes next to the trig function? What's the angle this time? Yes, you do. Ah! Of course, they told me the angle. It's X. Equals adjacent over hypotenuse. Hey, you know what? Here, they've given me the cosine value, and I want to find the angle. I want to go backwards. How do we go backwards? Right? Whatever the button is called. I think those are the big three. It's shift or second function or inverse. So on my calculator, I'm going to go shift cos. By the way, if you wanted to show work or if you wanted to write it out, that little -1 as an exponent is the symbol for inverse. It's a dumb symbol. We should have picked something else as mathematicians because it looks like an exponent, and it's not. And you'll have to put this in brackets. You'll have to go 7 divided by 15 because you want the inverse cosine of that whole thing. And if you do that, 62.2 degrees. B. There's angle Y. That 8.1, opposite, adjacent, or hypotenuse. Opposite, you say. That 14.5. Which trig function? Sine. What always goes next to the trig function? Which in this case, because I asked you to. Come on, you've missed that joke. Why? Because I asked you to. Why? Because I asked you to. What? Nothing? Okay. Tough audience. 8.1 over 14.5. By the way, there's a symbol for angle, so sometimes you may see them put that little symbol in front. That's angle Y. It's sort of like an L that's been stepped on. It's meant to look like an angle. 8.1 divided by 14.5. And I get 33.96. You know what? If I go to 1 decimal place, it's going to be 34.0. Yes? You're going to be doing a lot of finding missing sides and finding missing angles. You're going to be doing enough of it that it's worth getting monotonously good and speedy on your calculator to do it. You'll appreciate it, trust me. There are 2 terms that we use in physics. We have an angle of elevation and an angle of depression. So underneath the angle of elevation, draw a little dotted line like this. An angle of elevation would look like this. For an angle of elevation, you raise your eyes, and this would be angle theta. So if you're doing a problem and it talks about an angle of elevation, you want to think, oh, they're talking about that one when I draw my little picture. Then there's the angle of depression. And the angle of depression, and I'm doing that dumb joke on purpose, typically what they mean is you're standing up high somewhere and you're looking like that. You lower your eyes, because of course when you're depressed, you do lower your eyes. It's the angle of depression. That's the most common one for kids to mislabel. They'll see an angle of depression and they just want to put it on the ground part of their triangle. No, it's going to be up there somewhere. And what's your homework? All of it. Holy smokes, short lesson for a change. You can do the homework right on here. The answers are at the very, very end. I even stuck a couple of word problems for you to kind of get the hang of. Your hint is draw a little picture for both of them, DULP. And there's the answers.